This is part 2 for the 2004 Honda Accord. If you remember from part 1, we had a 130 milliamp draw, which will kill the battery in 2 to 3 days. Well, part 1, we narrowed it down. We thought this switch was bad, but the switch was not actually bad. There's a MICU under here, which is part of the fuse box. It's a multiplex system, and it communicates with the switch here. Well, the switch is not bad, and I'll show you how we found that out. So what I did is, after doing some more research, because we still have a 130 milliamp draw, I'll show you the order of operations we got to the answer. But before I do that, I do have a power supply hooked up to maintain battery voltage while we're doing all the tests. I have the Autel box out, the scan tool out for the Autel. So it's reading amperage, an amp clamp, all that stuff, right? So I printed some diagrams off, and this schematic here is the pinout for the connector on this vehicle, which is this white connector right here. So what did I do to troubleshoot this? Well, I used my breakout leads and I started plugging all the power and grounds in one at a time. And what I did, and I'm using these breakout leads, breaking it out from here to the switch, and I can also use an oscilloscope if I need to. And because normally this would plug into the switch. I was plugging them in one at a time until I got my 130 milliamp draw. Well, I noticed when I plugged in pin 21, the power door locks, that's when my 130 milliamps came back, is when I got this. So I got 130 right there. Well, if I unplug that, oh, also got my door jar switch closed. But if I unplug that pin, which I know from the schematics, I use this one right here. Sorry, I'm trying to film at the same time. If I unplug that, it goes down to my 0. Well, I'm on a 10 amp scale, but if I was on a 200 milliamp scale, it's actually like 4 or 5 milliamps, which is very within the range. So I'm like, okay, my draw's gone. Well, if I plug that back in to pin 21, like I said, it goes back to my draw. Which, if you look on the schematics here, pin 21 is power door locks. So then I'm looking at my schematics up here. It's different circuitry. It's a CAN B bus system for your multiplex system. I'm going through all these schematics here, right? Well, pin 21 on the power window master switch goes to this driver's door key cylinder switch. One on lock, so it goes from 1 to ground, it unlocks it. Goes from 2 to ground, it locks it. There's your key going to the switch. Like, okay, so I want to get to that switch. So I pop off the door panel right there, and the harness is right here, and it goes to the door switch under. It's hard to see in there, but that's the door switch, your key switch right here, and it goes through into the harness to your switch. So basically that key switch plugs into this power master window switch. So when we unplug this power master window switch, it takes this switch out of the equation. Hence in part 1, that's why our draw went away and we thought it was that switch, but it's not the switch. So then, if you're looking up some schematics, well, that's a bad glare. Let me find it here. Pull up the schematics. Here's the 3 wires, gray connector. 3 wires in your gray connector. Well, if you take the key, and we'll notice this real quick. See how this is turned to the right like 30 degrees or so? Well, that's not supposed to be like that. When I took this door panel off, I remember looking over this and I noticed this thing was turned a little bit. Well, if you put your key in and actually put it back, look, it goes away. Let me do that again. So it's straight. So I'm going to turn this to lock. And look, it's drawing your amperage. It went to 0 amps even though I'm holding it there. If I let go, so I'm going to go to lock, let go. Use your amperage and it'll go to 0. Sorry about my finger in the film. Went to 0. If I go to unlock, let go, you can do the same thing. Goes to 0 after a little bit. There it goes. It's actually 4 or 5 milliamps if you're on another scale. Well, if I pull this all the way to the right and I start pulling out and turning back right there, it's stuck there. Oh, look, it's stuck at 130 milliamps. And it never goes to 0. That's where the draw was at. Was in this switch right here. So it's stuck on unlock. So it's taking the signal from 1 to ground all the time. It's stuck there. That is what's causing this draw on this vehicle right there. Well, if I put it back in, turn it where it's supposed to be normal, now it's going to go to 0. So again, if I go to lock, even when I'm holding it on lock, holding it there, it stays at 0. If I go to unlock and hold it on unlock, it doesn't go to 0. It stays at 130 milliamps the whole time. So I think what happened is when they're pulling it out, they pulled out too soon. It's stuck there, and it's stuck at 130 milliamps. That is why when we unplug this switch or the pin to 21, either or, the draw goes away because of this tumbler right here. So simply all I gotta do is put it back in, straighten it out, and then it goes to 0. So the other question is, so if I go like this, I'll do it again. So I'm stuck on that position, 130 milliamps, it'll stay there. Well, what happens when you lock and unlock the door with the key fob from here on out? So I'm going to hit lock. Amperage draws way up, obviously, because it's locking all the doors and all that stuff. But look, it's still going to stay at 120, 130 milliamps. If I hit unlock, amperage is going to go way up again because of, you know, the interior light coming on, the door locks. So like right now, your light's on in there. You can see the lights on. But look at this. Once the light turns off, this will stay at 130 milliamps because it's still stuck in this position right here. So let me let that time out a little bit. It's going down right there, 130. But the light went off, but we're stuck at 130. So no matter when you unlock and lock with the key fob, it's still mechanically stuck in there. And that's why the draw was there the whole time. So that was kind of the order of operations, how we got to that point. Now, if I put this back in, you have to put the key all the way in. So I won't even turn it to get it all the way in. And then the draw goes away. So that was the problem right there. We had to use the breakout leads. I had the Autel hooked up. I was using the oscilloscope on the Autel with my amp clamp to go around the battery. Or you can use your ammeter in series, but this one's rated for, 10 amps. I know we went over 10 amps a little bit, but I don't want to blow a fuse in here, so I was using my Autel oscilloscope to do all that. So that's the actual issue with this. So what we're going to do now is put it all back together, and that'll fix this 2004 Honda Accord parasitic draw. It's a good thing we never end up replacing the switch or buying a MIC-U, because that would have got very expensive, whether, you know, for the part and programming and labor and all that, when it was simply something like this. I could see how somebody could go down the wrong rabbit hole troubleshooting this thing because of that. And again, the MIC-U controls all the door locks and windows for this 2004 Honda Accord. Before I end this video, I took all the breakout leads, I plugged it back in. We have no draw like we did before, but to simulate the draw, we're going to turn it to the right and pull out. Too soon, stuck in that position, 130, 140 milliamps, and it never goes away. Unless, if I unplug this guy right here, if I unplug that draw will go away. So let me pause it so I can set my camera down. So I unplugged it, and the draw went away. Let me plug it back in. Let me set my camera down. I plugged it back in. The draw's back up. Why? Well, because that is in that position. So let me turn that back off like it's supposed to be. And then the draw goes away. Like I said, it's all because when it's stuck in the unlock position, which is index 1. It goes from power coming in, volts and amperage going to ground. So that is the issue with this. So now all we got to do is put everything back together. I'll do a battery test for her since we got the car you know, here to work on. Got the Autel battery tester there. We can test that. You know, using our new Max Assist Ultra scan tool. So we can go in there and do that as well. Which I'll have some more videos on this scan tool as well, and other when I do work on other cars. So that is it for this 2004 Honda Accord with the parasitic draw. Well, I know I said I was done, but since we're here, we're going to go ahead and do the battery test. I got the battery tester from Autel hooked up. You can go to battery test. You can do in-vehicle, out-of-vehicle. If you do in-vehicle, we'll check the battery, the starting system, and the charging system. I know the starting and charging system is good. So I'm just going to do auto-vehicle test. This one's got 500 code cranking amps. So you set this to 500. Flooded, cold cranking amps 500. You hit start, 12 volt battery. And do its test. Should be a good battery. It says state of health 100%, state of charge 100%, voltage is 12.66. Capacity is 500 cold cranking amps and measured at 522. Temperature is 71 degrees Fahrenheit. How does it know temperature? Well, it's got a temp sensor inside of this negative lead there. So you can go to report, you can email it, you can do all that stuff. So this battery is good. So yeah, now what we're going to do is we're going to plug it into the car and do diagnostics and then make sure everything's clear and this car will be good to go. So we're going to go ahead and check the amperage with the amp clamp now. Now this amp clamp is a lot more accurate above 1 amp. Below 1 amp it's not as accurate. They make special amp clamps for that. That's why I've been using the DMM in series. But just to show you, so I got my VCMI hooked up. It's linked to it via Wi-Fi. I'm using my oscilloscope. There's a 4-channel oscilloscope on this. I'm just using one of the channels. You can also use it as a multimeter, DMM, function generator, and it's a J-box for a pass-through device. So, and it communicates to the vehicle. So I got my amp clamp hooked up. I'm in my oscilloscope. I'm going to go in here. And you can go in here and you can pick certain stuff you want to look at, and it tells you waveforms and all that stuff, right? But what I want to do, because I went too far back out, go to oscilloscope. Man, that glare is terrible. Oh well. So what I want to do is I want to go to my probe. I want to go to amp clamp there. We're going to zero it out. So I'm going to turn my amp clamp on right here to setting 1, which is a 1 millivolt per 10 milliamps. So turn it on. I'm going to zero it out by pushing this button. It zeroes it out. We go to a bigger scale here. Zero it out. Take my amp clamp, hook it up. Like that. If you go the other way, it'll be on the wrong side. It'll be below 0. You just got to reverse it because it's inductive. So let's go to a 1 amp scale. You go to your measurement tab. Let's do DC average. So we're drawing around 400 milliamps. Why? With the doors open, stuff like that. So if we shut this door and we lock everything, see the amperage jump way up. See how many amps it's drawing. It's drawing a lot of amps when you lock the doors and hit the horn. Now let's see what it's drawing. When it shuts off, now it's down to 94 milliamps. When everything shuts off, it'll go down to its 4 or 5. But like I said, that amp clamp, they make better ones that are below an amp. They're a lot more money, but typically if I'm doing anything below an amp, I'm using a DMM in series. So, but that's just part of the oscilloscope function. There's many functions on this Autel Ultra that you can use. But that was for that part. So what we're going to do now, that'll eventually go down to 4 or 5 milliamps. But what I want to do now is I want to hook up my VCMI and make sure there's no codes in this vehicle. So now I want to hook up my VCMI to the vehicle to do a full system scan and clear any codes out that we may have set. So go in here. Here's all your leads, alligator clips, breakout leads, but we're going to need this cord here to communicate with it. This Autel Ultra also comes with a docking station, so you'll see more in other videos I do, but we're going to hook this up now to the car and do our diagnostics. Alright, so I got the VCMI hooked up. Key on, engine off. We're connected. Go back up to the Autel. Go to diagnostics. I have the Honda saved in here from before, but if you didn't, you can do an auto VIN, a manual input. You can scan the license plate, VIN number, and get everything set up. So what I want to do is the 04 Honda Accord. We're connected via Wi-Fi to the VCMI. This thing does have a screen recorder on it too, so instead of having this glare, maybe I'll do that one day. So it's going to establish communication to the vehicle. So let me pause this until this gets set up. Alright, so what you can do now is you got topology, or you can go to list. You can go into each module, you can scan each module. Here's all your functions. We're using the Honda program. But topology, if you go to fault scan, it'll scan each module and it tells you what bus they're on. So like this is Lin bus, is this bus right here. It's telling that. So it tells you what bus every module's on. Like ABS has got a fault code in it. Gonna look at it sometime. Maybe it's a battery voltage low code, who knows. So but it's got all the data in here to all the hardware, the factory software, all that stuff that's in this scan tool. Be able to read all these codes and communicate with everything, which is really handy when you're trying to determine a bus issue, because it shows you everything on it. So we'll let that go ahead and scan. Let's continue in the scan. Before we had a body code, I believe it was a B1140. This time we have nothing because it's green. There's no faults. It's a pass. Well, why was there a fault before? It's because the switch right here was stuck. So it always had a circuitry code in there. Well, that's gone now. So we'll let it continue to scan for all these modules. But yeah, it's very, and then it's an awesome scan tool. Like if there's a code in here, you can go to Intelligent Diagnostics. It gives you certain data. Like I said, as I make more videos, I'll use the scan tool more than the 906BT, the Bluetooth one. So this is the Ultra one, which has been awesome so far. Yeah, so if you go into report under list, you can, I'm not going to put the mileage in, but if you look here, the battery or ABS has a battery voltage failure because it had low battery voltage, so we'll just clear that out. But nothing in the body control module. But what you can do is you can hit Intelligent Diagnostics if you're connected to the internet. If there's a TSB, it'd be in there. You can go to DTC analysis, repair assist, depending on it. This data, sometimes it'll show you component measurement stuff, repair tips. You can take it with a grain of salt, but gives you all kinds of data to go off of. So I guess there's nothing in this one, but sometimes it'll come up with, you know, possible causes, but we know it's just because of a low battery. But depending on the code, you can get a lot more information in there. Oh, and also the oscilloscope has a waveform library in there too that people load data to, so you can use that to compare cam crank waveforms, depending on what you're searching for. So all we're going to do is clear the codes out, and that'll be it for this vehicle. So now I'm in the body control module. You can go to, I don't know, like your door locks. It's part of the B can. Go to trouble codes. No trouble codes because we, well, fixed the problem. But you can roll windows up and down. You know, you got your active tests and all that stuff. Lock doors, depending on what you're doing. There's all kinds of information. You know, you can adjustments if you want to reset your windows. If you're to put a new module in, which you put one of these in, you have to reset your windows and your key fobs and all that. But we don't have to do any of that because we never replaced that. So the scan tool is awesome. The Max Assist Ultra, just a lot of stuff you can do in here. So that is it for this 2004 Honda Accord with the parasitic draw. All right, so I know I said the B1140 was for the issue we had. It wasn't. It was actually a window. The code we had from part one was a B1140, which had nothing to do with the door locks. We know the door lock issues because of this guy right here, which we fixed. We know the issue with it. But since we had that code in there before, we're going to go ahead and go to adjustment for the windows, power window for the driver's side. Got to reset this and just follow the prompts. Buddy, move the window all the way down. Hold it down. Hold it all the way down. Let go. Evan's giving us a hand. So hit yes. Says pull it all the way up and hold it for 2 seconds. Okay, go all the way up and hold it. I'll tell you when to let go. Keep holding it. Don't let go. Keep holding it. Keep holding it. Let go. Then it's been reset. So that'll fix that one, because that was the driver's side. It needed to be relearned. We've been messing around with a lot of this stuff, so if that's relearned, we know the parasitic draw was from this, so that's fixed. So I just wanted to show you guys that too. This thing's got an awesome battery on it, so we've been running this since 1 o'clock. It's almost 5 now when it's 100%. So since 1, it's almost 5, so we've been running for 4 hours, and it's only went down 17%. So it's supposed to last 8 hours. So using it, which is, we're well on track for that. So that is it for this 2004 Honda Accord that had the parasitic draw.